All right, so today's lesson really, honestly, does not need any examples. And that's not my words, that's classes before you. But I'm going to go ahead and give you some just in case. Okay? And I think you'll see what I mean in just a second. The instructions on this problem right here are solve. What do you do first if we're solving this for x? Add 1, right? So if I add 1 here and add 1 here, I get 3x plus 4 raised to the 1/3 power equals 27. Then what? Well, this is the cube root, right? You're taking the cube root. So how do you undo a cube root? Cube it. Here and here. What do we get on the left-hand side? Excellent. 3x plus 4. What do I get on the right-hand side? What, you guys don't know 27 to the 3rd power off the top of your head? I'm just teasing. 19,000? 683. Thank you. How do I solve this? This is like super simple, isn't it? 3x equals 19679. Good. Divide both sides by 3. X equals. Can somebody tell me why I did this particular example for you? What's your answer? Tell me what the answer is. Why did I do this example for you? Because your answer is a decimal. And earlier today, people were freaking out because it's a decimal. Guys, we've done problems that our answer is a decimal before, haven't we? And that's okay, isn't it? Yes. Is it okay to leave our answer as 19,679 over 3? Yes, because it's not evenly divisible, right? Is this the exact answer right here? No, it's rounded, isn't it? So part of the problem they were having is that they were putting this number right here back in for x. And guess what? It wasn't 26. It was like 26 points, because we rounded up, right? And they were, freaking out a little bit. Don't. Okay? If you're going to plug it back in, which you should, to check to make sure it's right, you got to plug the actual number in. So actually do this, and then use that second answer to plug it back in here. Multiply by 3, add 4, raise it to the 1/3 power minus 1. And when you do that, guess what your answer is? 26. Okay? You got it okay? All right. Let's try this one. 5x minus 6 to the 3/2 power was x to the 3rd. Why do you think I'm doing this example for you? Yeah, the exponent. It's not something that we've done in a while. We've done it before. We just haven't done it in a while. So that's also another reason to freak out. No, it's not. What do you want to do? So you want to multiply by the reciprocal, right? The exponent. You want to multiply the exponent by the reciprocal. Wait, which exponent? Oh, both of them, right? You want to multiply both exponents by 2 over 3, like that? Because what happens to this exponent on this side then? Yeah, if we multiplied it out, I'd get 6 over 6, which is 1. So all I have left on that side is 5x minus 6. Very good. What happens on the right-hand side? What am I doing with them? Multiplying, so I would get 6 over 3. 2. Or I could simplify the 3's and I would still get 2. Right? Uh-oh. It was before Christmas. It was last year when we did these last time. What type of problem is this? Good. It's a quadratic, right? How do we solve quadratics? Well, we get them equal to 0. I know it would be easier to just subtract x squared from both sides, but we like to keep a positive x squared value, right? A positive leading coefficient. So let's go ahead and move these two terms to this side. X squared minus 5x plus 6. What were the ways that we kept listed on the board for quite a while to solve a quadratic? Yeah, we could factor it. We could graph it. Good. Oh, yeah, quadratic formula. We could do completing the square. Lots of different ways, right? Okay, how do you want to do this one? Oh, factoring. Okay, so I got two binomials. What multiplies to be 6 and adds to be negative 5?
3 and 5. Or 3 and 2.
Negative 3 and negative 2. If these are my factors, what do I do with each one of those factors? Set it equal to 0. So x equals 3 and x equals 2. Which one's right? Well, we got to plug them in, don't we? Okay. Is it possible that one of them's right? Is it possible that both of them are right? Is it possible that neither one of them are right? Yeah, let's plug it in. 3. 5 times 3. 15. 15 minus 6 is 9. What's the square root of 9? You guys are hurting my heart a little bit. 3. What's 3 cubed? 27. So on the left-hand side of the equation, we have 27. 3 cubed. Does 27 equal 27? Okay, then this is an answer. That is works. That's right. Okay. What about 2? Let's check and see. Okay, let's try it better. 5 times 2. 10 minus 6. 4. Square root of 4 to the third power is 8. What is 2 to the third power? 8. Does 8 equal 8? Yes, then this one also works. Okay? So on some of these that you're going to have to do, I'm going to tell you which one's a circle. Okay, you ready to know which one's a circle? 3. Oh, well, why didn't you just pick one up?
Oh.
No, that was totally my fault.
No, that's my fault.
Take one. Okay. Okay, I want you to circle number 3. Circle number 3, number 8, number 10, 12, and 13. 3, 8, 10, 12, and 13. Now, there's a little confusion earlier, so let me make sure that everybody's okay with it, okay? Are you allowed to do number 4 for extra credit? No. Why are you not allowed to do 4 for extra credit? Yeah, I did. That was the example the first example. Are you allowed to do number 11 for extra credit? No. Can you do any of the rest of them that are not circled for extra credit? Yes. Okay. Do you have any questions? Thank you. Do you have any questions? Guys, this is all stuff we've done before. We just did it with square roots before. Now we're doing cube roots. So let's take that information that we already know and just transfer it, okay? Got it? My dear. Have a great day. Peace.